Yes, good afternoon to everyone. So today in the third lecture, we are going to start with another concept in the same unit, that is unit number 1, that is change of order of integration. So here, what do you mean by change of order of integration is? Actually, you people have seen this in the Actually, we have seen this change of order in while defining that is double integration. Okay, in the double integration, so I explained you two types of the definition. What is one is x equals to a to x equals to b, and y is equals to y1 of x to y is equals to y2 of x, f of x comma y into that is sorry here dy dx. This is one type. Okay, in the similar way, or I said one more, that is integration, double integration. One is y is equals to something some constant c to y is equals to that is constant d, and here x is equals to x1 of y to x is equals to x2 of y, f of x comma y into dx into dy. Here only you can observe that is change of order. Change of order means what? Here we have taken dy dx and here we have taken dx dy. By taking dy dx, here we have the limits of x is ranging from a to b, but here it is ranging from x1 of y to x2 of y. Okay, and similarly here the limits of y are y1 of x to y2 of x, but here the limits of x are constant c to d. Okay, so this is there is change of integration. So now I would like to have examples on this. Before going to examples, I would like to give you that is how one can I would like to give you the introduction about what that is change of order. Okay, so now here I'll give you change of order of an integration. Change of order of an integration generally changes the limits of integration. That is, change of order of an integration generally changes the limits of integration. Okay, that is the main the concept behind this change of order of integration. If you change the order, then definitely limits will changes, and the new limits are examined by geometrical. The new limits are examined by geometrical region on which integration is being carried out. Okay, so now so this is the what that is the introduction about that is change of order of integration. So now I would like to take an example and explain you so how one can do the examples on this change of order. So in the beginning I'll take very simple example, that is example number 1. Change the order of change the order of integration, and then evaluate integration 1 to 2, integration 3 to 4 xy dy dx, in the beginning. So we'll write what is given. Let I is equals to integration 1 to 2, integration 3 to 4 x into y dy dx. Okay, so now allot the limits. So here this is first one is what with respect to y is there, so therefore this is y is equals to 3 to y is equals to 4, and here it is with respect to dx is, therefore this is x equals to 1 to this is x equals to 2. So here I'll write I is equals to x equals to 1 to x equals to 2, y is equals to 3 to y is equals to 4 xy dy dx, and call it as equation 1. Okay, so now so as here we have said, that is integration, that is by the geometrical reason on which the integration is being carried out. Okay, that will check. So in which geometrical reason we are going to carry out a integration, that we need to check. So now here I'll write in integration 1, x varies from x equals to 1 to x equals to 2, and y varies from y is equals to 3 to y is equals to 4. Okay, so now what is that? X equals to 1, x equals to 2, y is equals to 3, y is equals to 4. In a geometry we need to understand. So now you can say you can draw a geometrical figure about what these limits. Okay, so this is origin O, we can say x axis, y axis I have drawn. So now so here what we'll do is, now here x equals to 1 means what? X equals to 1 means it is a straight line which will be parallel to y axis, at x equals to 1. So therefore this line is what? That is x equals to 1. This line is x equals to 1. Next is x equals to 2. X equals to 2 is again the same line. Okay, that will be parallel to y axis but at x equals to 2. So here somewhere here it is what? X equals to 2, and I'll draw here, that is this is x equals to 2. Okay, so this is x equals to 1 and this is x equals to 2, and this point is what? That is 0 comma 1. One can very easily understand this point is 1 comma 0, because on x axis this is at x equals to 1, so therefore x comma 0, and this is 1 comma 0, and this is 2 comma 0. Okay, so now next is y is equals to 3 and y is equals to 4. We know that y is equals to 3 means which is a line, this is a line which is parallel to, that is which is parallel to x axis. So therefore at y is equals to 3. So somewhere here it is there. Okay, so we can draw it like that. So I'll draw it in. So this is y is equals to 3. This is y is equals to 3. Similarly, y is equals to 4. Somewhere here. Okay, and just you draw a line which is parallel to what? That is parallel to x axis. Okay, so now you can see this whatever they have given, okay, the area which is bounded by x equals to 1, x equals to 2, y is equals to 3, y is equals to 4. Then which is that area which is bounded by these 4 lines? One can very easily understand. So this is the area which is bounded by x equals to 1, which is bounded by x equals to 1, x equals to 2, y is equals to 3, and y is equals to 4. This is a common reason where we are going to carry out, that is integration. Now for this equation 1 or integration 1, we need to change the order. Change the order means what? Whatever dy dx is there, we need to write it as dx dy. If you change the order, then limits will get changes, because here only we said generally change of order of an integration generally changes the limits of integration. So therefore limits of integration will changes now. So beginning only you have to what? Analyze it. You can see this. So first in the first integration they have fixed, that is limits along x-axis. Limits along x-axis means what? That is the vertical lines. You can very easily see them. Okay, this is one vertical line, this is another vertical line. One vertical line is x equals to 1, another vertical line is x equals to 2. And later they have fixed the horizontal lines. You can see that is y is equals to 3 to y is equals to 4. That means horizontal lines. That means first they have fixed vertical lines, and later they have fixed, that is horizontal lines. In the similar way, if you change the order, what will happen is first you have to fix, that is vertical lines, and next you have to fix, that is horizontal lines. Okay, so now so here in this particular example, so I think there is no much change you can observe, but still we will write it. Okay, so now yes, by changing the order of an integration we get following limits. We get following limits from the above figure. Okay, so now here I'll write, by changing the order, here I'll write x varies from, sorry, first y varies from, okay, you can tell me. So from where y varies? Y is equals to 3 to y is equals to 4. Y varies from y is equals to 3 to y is equals to 4. And x varies from x equals to 1 to x equals to 2. X equals to 1 to x equals to 2. Therefore equation 1 can be written as integration x equals to 1 to x equals to 2, y is equals to 3 to y is equals to 4, xy dy dx is equal to, we can write double integration. Here first the limits are with respect to x we have written, so here we'll write with respect to y. Y is changing from 3 to 4, y is equals to 3 to y is equals to 4, and x equals to 1 to x equals to 2, xy will remain as it is, but order will change. Dy dx becomes, that is dx dy. So now which is equal to, first integration you can keep as it is, y is equals to 3 to y is equals to 4, then integration of xy with respect to x, that is y will be kept constant, then integration of x is x square by 2, that is x square y by 2, and the limits are x equals to 1 to x equals to 2 into dy. Now put upper and lower limit. You can bring 1 by 2 outside, and now y is equals to 3 to y is equals to 4, Then now put x equals to 2. Then 2 square becomes 4, that is 4 times y, minus 1 square is 1, that is y into dy. That means 1 by 2 integration from y is equals to 3 to y is equals to 4. 4y minus y, that is 3y into dy. So now which is equals to, you can keep that 3 outside because it is constant, you can keep it outside, 3 by 12, right? Then integration of y is y square by 2, and the limits are from y is equals to 3 to y is equals to 4. Therefore integration from x equals to 1 to x equals to 2, y is equals to 3 to y is equals to 4, xy dy dx is equal to 3 by 2. So now 1 by 2 also you can keep it outside, and now put upper limit, y is equals to 4, 4 square is 16 minus 3 square is 9, so which is equal to 3 by 2 into 1 by 2, that is 3 by 4, 16 minus 9, 16 minus 9 is how much? 16 minus 9 is 7, okay, so this is 7, which is equals to 3 7s at 21, 21 by 4. So this is the final answer. X equals to 1 to x equals to 2, y is equals to 3 to y is equals to 4. So 21 by 4 is the final answer by changing, that is order of integration. By changing order of integration, one can do like this many examples. So therefore this is a one example. Similarly here by keeping the same example, I would like to do one more example. Here whatever xy is there, instead of taking xy, we can take x plus y also. Okay, so there is no much change in this particular example. So here only I'll change, and I'll show you how one can do that example also. Okay, so therefore example number 2. So only this much will changes. That is example number 2. The same thing. Here it is x plus y. So here it is x plus y you will get, and now here also it is x plus y you will get. Everything is same, only what, that is x plus y, that is xy will be replaced by x plus y. So therefore here it is again x plus y. So now this is also x plus y only. So now this x plus y, that is integration of x plus y with respect to x is, that is x square. So this one I'll rub. Yes, so integration of x is, that is x square by 2, integration of y with respect to x is xy. So here it is x equals to 1 to x equals to 2, it is dy. Now integration from y is equals to 3 to y is equals to 4. Now put upper and lower limit. So if you put x equals to 2, then it is 2 square is 4, 4 by 2 is, that is 2, plus it is 2y for lower limit, and for upper limit for upper limit it is this much, and for lower limit it is 1 by 2 minus y, okay, into dx, which is equal to. So now integration from y is equals to 3 to y is equals to 4. So now this is 2y minus or minus plus, this is 3y, that is 3y, 2 minus 1 by 2, that is 3 by 2, plus 3 by 2, that is plus 3 by 2 into, that is dy. Now integrated, that is 3y integration is 3y square by 2 plus this is 3y by 2. Now it is from y is equals to 3 to y is equals to 4. So now integration x equals to 1 to x equals to 2, integration y is equals to 3 to y is equals to 4, then 3 by 2 x plus y into dy into dx is equals to, so in that 3 by 2 is common, you can keep it outside, 3 by 2. So here you will get y square plus y, and y is running from 3 to y is running from 3 to 4, which is equals to 3 by 2. Now put upper limit is 4, that means it is y square. 4 square means 16. 16 plus 4 minus 9 plus 3. So which is equal to 3 by 2 in the bracket 20 minus 9 plus 3, it is 12. So which is equals to 3 by 2 into 8. So that is nothing but 2 ones are 2 fours are. So therefore 3 fours are, that is 12. So the answer is, the final answer is the final answer is, that is 12. So integration x equals to 1 to x equals to 2, integration y is equals to 3 to y is equals to 4, x plus y, this is dy dx. So this is the final answer. Yes, so we have seen 2 examples. So now I'll take up one more example, so it will be much typical than what these 2 examples. So let us start one more. Okay, so example number 3, evaluate integration from 0 to 2, integration from 1 to e to the power x dy dx by changing order of integration, okay. So now for this particular example, you can see here there is no function. That means what? If there is no function means what? It is 1. Nothing to worry, one can very easily do this kind of what examples. So now I'll write the given. Let I is equals to integration from 0 to 2, integration from 1 to e to the power x dy dx. Okay, so now allocate the that's what the limits for allocate the variables for the limits. Dy is first, so therefore dy is there. So here y is equals to 1 to e to the power x, and here dx is there. Therefore it is x equals to 0 to x equals to 2. So now I'll write x equals to integration from x equals to 0 to x equals to 2, and here I'll write y is equals to 1 to integration y is equals to 1 to y is equals to e to the power x. This is dy dx, and now we can call it as equation number 1. Yes, so in integration 1 we'll write in integration 1 x varies from x equals to 0 to x equals to 2, and y varies from y is equals to 1 to y is equals to e to the power x. Okay, so now we need to draw a graph of these limits. Okay, so now here I'll take x axis, y axis, this is y axis, this is x axis, here it is origin O. Okay, so now you can see x equals to 0. line x equals to 0 means what? That is y-axis only. Okay, so therefore you can write it as what? X equals to 0. See, y-axis equation is x equals to 0, x-axis equation is y is equals to 0. One can very easily understand this. Okay, and next is x equals to 2. X equals to 2 means what? That is the line which is parallel to x-axis. The line which is parallel to, the line which is parallel to y-axis and passing through x equals to 2. Okay, so this we will call equation x equals to, or line x equals to 2. Now next, y is equals to 1. Okay, already you people have seen in the last example, y is equals to 1 means that is a line which is parallel to x-axis at y is equals to 1. So somewhere here we can say. Yes, so this is what? The line y is equals to 1. Line y is equals to 1. Okay, so next one more is there. Y is equals to e to the power x. Then how one can draw the graph of this? Very simple. Just to put x equals to 0 in this equation. Okay, so y is equals to e to the power x is there. If x equals to 0, then e to the power 0 is 1. So 1 means this point is 1 only. Okay, and that will be crossing this particular point. Now put y is equals to 1 or x equals to 1 or x equals to 2. You can put x equals to 2. If you put x equals to 2, then it might be y is equals to e square. E value is 2.7. 2.7 square is somehow it is 3 square is 9. So therefore 2.7 square is lies between, I think, 7 to 9. Somewhere here we can say. Okay. Yes, somewhere here we can say. Therefore just you join them. It is a curve. So therefore it will be like this, and this curve will be calling as y is equals to e to the power x. But what is this point? Very important is what is this point and what is this point. This point one can very easily understand, because this is y is equals to 1 means what? On this particular y-axis x coordinate is 0. Therefore we can call it as that is 0 comma 1. But what is this particular point? One can again very easily understand. I put x equals to 2. Therefore here it is x equals to 2 means what? X coordinate is 2 and y coordinate is, of course, that is what? If you put here, if you put x equals to 2 means y is equals to e square. Therefore it is e square. So even I'll show you by solving those two. Okay, so how one can get those two, right? So now here next I'll say solving which we need to solve, that is this line, this curve and this line. Okay, solving y is equals to solving x equals to 2 and y is equals to e to the power x, we get a point of intersection. We get a point of intersection, that is 2 comma e square. Okay, 2 comma e square. Very simple. X coordinate is 2 only, and if you put x equals to 2 in this, then y coordinate becomes e square. So therefore x coordinate is 2, y coordinate is e square. Okay, so therefore this is a point of intersection, and this point of intersection is what? That is 0 comma 2. Now what is the region of integration? One can very easily see that here you can write, that is this will be the area of, that is integration. Okay, this will be the area of, this will be the region R on which we are integrating. So here I can call it as what? Region R. Okay, region R we can call. Yes, so by the above figure, region R is the area of region R is the Then R is the area bounded by, you can see area bounded by y is equals to 1, x equals to 2 and y is equals to e to the power x. Okay, by the above figure, reason R is the area bounded by y is equals to 1, x equals to 2, y is equals to 1 means this line, x equals to 2 means this line and this curve, and y is equals to e to the power x. Okay, so by this that's what area of integration is bounded by these three lines. Okay, so next what we need to do in the next case is we have to change the order. Yes, by changing order of integration, by changing order of integration we get the following limits, from the above figure, So now here we can analyze. So what they have given is like this. First integration is changing x is from 0 to 2. That means what? That they have taken the vertical lines first. Okay, they have taken vertical lines first. Okay, and next they have taken, that is, first they have fixed vertical lines and later they have fixed, that is, horizontal line. Okay, that is y is equals to 1, and next that curve, above curve. Okay, this line y is equals to 1 to y is equals to e to the power x. That means first they have fixed, that is, vertical lines, and later they have fixed this y is equals to 1 and this above curve y is equals to e to the power x. So now we need to change the order of integration. That means what? First we need to fix, that is, horizontal position. That means horizontal one line is already fixed. Okay, and one more line is there, and that line is here. One can very easily understand this. Okay, one more line is this. You can see this. This is one more line. But what is the equation of that line? You can see here it is parallel to what? It is parallel to what? That is x-axis. Okay, and crossing the point 2 comma e square. That means this equation is y is equals to e square. Okay, so therefore if you fix horizontally first, that means your y is running from y is equals to 1 to y is equals to e square. Okay, therefore y varies from y is equals to 1 to y is equals to e square, because you want this much region. So therefore first we have to what? That is, fixed our horizontal line. So therefore y is equals to 1 to y is equals to 2. You can see the region is up from here to up to here, it is there. So therefore y is equals to 1 to y is equals to e square we have fixed. Next I don't want this whole area, I want only this shaded area, this region R. Therefore next curve is this. What is that curve name? Y is equals to e to the power x. Okay, I want to convert that in terms of what? That is, x equals to something y I want to convert. From this curve to this curve I am running. Okay, therefore next, x varies from, here it is in terms of y is there, y is equals to e to the power x. So how will write? If you apply log on both sides, you will get log y is equals to e to the log of e to the power x. That means x comes here and log of e to the base e is 1. Therefore what you will get? X is equals to, that is, log y. Okay, x is equals to log y. Therefore x varies from x is equals to log y to x is equals to log y means what? This curve to this curve. What is that curve name? You can see here, x equals to 2. So therefore x equals to log y to x equals to 2. Okay, therefore equation 1 becomes, okay, equation 1 becomes, that means what? Equation 1, in this equation we are changing the order. So therefore integration from x equals to 0 to x equals to 2, integration y is equals to 1 to y is equals to e to the power x, it is dy dx is equal to, we have changed the order, okay, that means first we need to write y. So y is changing from y is equals to 1 to e square, y is equals to 1 to y is equals to e square, and here x is changing from x is equals to log y to x equals to 2, and here it is dy dx. You can see guys, these both are equal, but here it is, sorry, this is dx, this is dy. You can see here it is dy dx, here it is dx dy, okay, and we are writing equal, but you can check the limits, both the limits are different, okay. So therefore, but both LHS and RHS yields the same answer, both LHS and RHS yields the same answer, okay, but it is by changing the order. So if you change the order, its limits get changed, its limits will get changes, okay. So now here start integration, that is integration, first integration y is equals to 1 to y is equals to e square. Here there is nothing, means what? Here 1 will be there, okay. Integration of 1 with respect to x is, that is x. So x is equals to log y to x is equals to 2, and here it is dy. Next, which implies that integration from x equals to, sorry, y is equals to, sorry, x equals to 0 to x equals to 2, and y is equals to 1 to y is equals to e to the power x dy dx is equals to, put upper limit, okay, that is integration y is equals to 1 to y is equals to e square, then it is 2 minus, that is log y, 2 minus log y into dy, okay. What is the integration of 2 with respect to y? That is 2y. What is the integration of log y? Integration of log y is y log y minus y, okay, and the limits are from y is equals to 1 to y is equals to e square. Put a upper limit is y is equals to e square, so therefore 2 e square minus e square log e square minus e square, okay. So for a lower limit, minus, that is 2 minus 1 log 1 is, that is log 1 minus 1, okay, which is equals to 2 e square minus e square. Log e square is there, okay, 2 will come outside and log value is 1, so therefore here you will get 2 e square, minus of minus, it is plus e square, here you will get, okay, minus, here it is 2, log 1 value is 0, okay, log 1 value is 0, so 0 minus 1 is minus 1, minus of minus plus 1, okay, so which is equals to 2 log e square, 2 e square get cancels, here you will get e square minus 2 plus 1 3, so therefore the final answer is e square minus 3. Therefore integration x equals to 0 to x equals to 2, integration y is equals to 1 to y is equals to e to the power x dy dx, answer is e square minus 3. So this is the example, that is third example by change of order, okay. So 2 more examples are there. I think you people can very easily solve those 2 examples by seeing this video. Now I'll start the next unit, that is unit number 2, vector integration. Very important, and this particular unit is almost depends on double line triple integration, and little bit over, that is geometry. So geometry means you need to understand, so how one can draw the figures by using the what, that is limits, that also you need to understand. So if you do that much, then one can very easily understand vector integration. Okay. So now we shall go to next unit. Yes. Unit number 2. Vector integration. Unit number 2, vector integration. In that, first we'll take up line integration. Line integration. Okay. So first we need to understand what do you mean by line integration is. Okay, and what is the difference between the normal integration and line integration. Okay, so guys, if you take a normal integration, that is integration I is equals to integration of something y into dx, if you take, and here if you allot the limits x equals to a to x equals to b. In this particular case, what actually you are doing is you are integrating, that is y is equals to, that is what, x. You are integrating y is equals to x. Okay, y is equals to x means what? That is this line. This is y is equals to x, we can say. You are integrating this particular line from the limits x equals to a to x equals to b. Okay, x equals to a to x equals to b along the direction of x. Along the direction of what? That is x. So therefore x equals to a to x equals to b we are doing. So therefore this is a normal integration. Okay, one can very easily understand. So this we are doing. Okay, that means this area we are finding. Okay, the area bounded by y is equals to x between the limits x equals to a to x equals to b we are doing. Okay, this is fine. One can very easily understand this general what the interpretation of what, that is integration. That is okay. But when it comes to line integration, okay, so before that line integration, it is a vector integration. Vector integration means what? We are doing integration on the vector fields or vector point function. Vector point function means what? You can very easily understand. In the last the class only I said, that is f is a vector point function and it will be written as f1i plus f2j plus f3k, where f1, f2 and f3 are functions of x, y and z. Okay, small f1, f2, f3 are the functions of x, y, z, and this capital F is called as, that is vector point function or vector field. Okay, so by taking this vector field, we are going to integrate along a curve, not along x-axis or not along y-axis or not along z-axis. We are going to do the integration along a curve C. Okay, that curve C means how? That is, you can see here, this is x and y axis in 2 dimension. I'll show. Okay, I'll not show in what, that is 3 dimension or in a space. I'll show you in the plane. So this is x axis, this is y axis, and somewhere here is your curve. Okay, this is curve C. Okay, I'll call this curve as what, that is C. So this curve C. So now we are going to integrate this vector field or vector point function F along this curve. Then if you do that, then we'll call it as that is a line integration. Don't confuse the name line integration. Sir, here it is line integration is there and you are showing a curve. Okay, even line is also what, that is curve only. So generally they have named it what, that is line integration. You can also call it as what, that is curve integration, but it is line integration, that is standard name is given, so therefore it is line integration. Don't confuse. Line integration means C should be straight line. No, C is what, any type of curve. Okay, any curve. So therefore what we are doing, that is by taking that is vector field or vector point function, we are integrating along this curve C. It is very strange, guys. You can very easily, you cannot understand it so easily as like what that previous integration, because previous integration is along, either it is along x-axis or along y-axis or along z-axis. That means with respect to one axis we were done, but now it is along, that's what C we are doing. If you take any point on this, if you take any point on this, okay, it will be changing in all the directions, along x direction, along y direction, and along z direction. So therefore if you take this particular what, that is particular what, the point, and if you draw that's what if you take any point on the curve and if you take a position vector, okay, position vector will be, that is a line passing through the origin to that particular point. Okay, so this will be representing x comma y comma z, and if this is a vector r or capital R, if you write, then it is xi plus yj plus zk. Okay, so this is what your position vector. Okay, position vector on the point on any point on that curve, any point on that particular curve. So therefore now I'd like to explain you what do you mean by that is line integration is. Okay, line integration is simple, that if you write integration of f means vector field or vector point function, okay, into dr, okay, along a curve C, then we call this as that is line integration. Okay, we call this as C, integration over a curve C. See, in the previous case what you had, in the previous case you had integration from x equals to some a to x equals to b, that is f of x into dx, or that is some function of what, that is x will write and dx will write. But here that is a function f is there, sorry, vector field f is there, or vector point function f is there, f dot dr. Okay, then here if this is r is the position vector, then what is dr? dr is I dx plus j dy plus k dx. Okay, that is what, this is the position vector, this dr means a small change. Okay, small change in the position vector, that means what, a small change along x, small change along y, and small change along that is z. Okay, small change along z. So therefore dr is what, I dx plus j dy plus k dz. Okay, therefore this is what, the line integral. That means integration of vector point function f over a curve C is called line integral, or else you can also write it like this also. Okay, that is integration over a curve C f dot dr divided by dt into dt. Okay, that t is any parameter. Okay, t is any parameter, like that we can write. Okay, so therefore this is called line integration. So therefore first I'll give you the definition of line integration, and later we shall go to examples on this line integration. And before that, two more concepts are there. One is in this circulation, and one more is that is work done. Circulation and work done. Okay, here whatever f we are defining in this, okay, that's what vector point function or a vector field f we are defining. So that is a general case. Okay, this is f is generally vector field we said, but in a circulation, if your f is velocity, f is velocity of a moving particle, velocity of a moving particle. Then circulation, okay, circulation of the particles around curve C is denoted by, that is curve C, that is F dot dr. That means if you want to find the circulation of the moving particle, the circulation of moving particle around the curve C, then it will be done by what? That is using a line integral. You can see integration over a curve C, F dot dr. F dot dr if you do, then that is a circulation. Okay, this is called circulation. Similarly, work done. So work done means what? I think you people might know well about what that is work done. Work done is a force required to move a particle from one place to another place is called work done. Then even work done is also what find by using what? That is this line integration. Then how is that? Here in this particular case, F is a force field. See, here it is velocity vector field, or velocity we can say, and here F is force field. That means F may can act in what? That is in a different physical physical concept. So in this circulation, F is a velocity vector field, and here in the work done, F is what? That is force field. Or force field means what? Force field means amount of force acting on a particle or acting on a body to displace. So therefore, F is a force field acting on a particle or on a body, on a particle. Then work done is integration over a curve C, that is F dot dr. Okay, then work done is what? Integration over a curve C, F dot dr. Okay, so F is, you know, that's what? Force field or force acting on a body. C means on which direction it will move. For example, here there is a body, and if you are applying a force, then it can move it like this. So then that is a curve. Okay, from one point to another point. Okay, from this point A to this point B, if it moves along this curve, along this pattern, then this is what? That curve C. So therefore, integration over a curve C, F dot dr represents, that is work done. That means if you have a force acting on a body, if you have a force field acting on a body, okay, then one can very easily find and that curve C, okay, in which direction it is moving. If you have these two, then one can very easily find, that is work done by that force on a particular particle by using this line integration. See, so here it will be acting as what? That is circulation if F is a vector force field, so velocity vector field, and here if your F is a force field, then this is the work done by that particular force. Okay, so like this, so we can explain this line integration. So in the next class we shall see examples on line integration and next concepts. Okay, thank you.